Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present about cryptology. Our group consists of 4 members, which is Nur Hazima, Engku Nur Amelia, Nur Amirah, and Zahira.
Introduction of Cryptology. Cryptology is the study of crypto system that can be divided into 2 main branches, cryptography and cryptanalysis. Cryptography is the science of secret writing with the goal of hiding the meaning of a message. Cryptography is the transformation of ordinary text into coded form by encryption and the transformation of ciphertext into plain text by decryption by Joseph Zelenka. In other words, cryptography is the science of securing data. Cryptography is the science of using mathematics to encrypt and decrypt data by Omar Rayad. Meanwhile, cryptanalysis is the analysis of cryptographic system and or its inputs and output to derive confidential variables and or sensitive data including plain text by Joseph Zelenka. Cryptanalysis is the science of analyzing and breaking secure communication. Cryptography itself splits into 3 branches, which are symmetric algorithm, asymmetric algorithm, and cryptographic protocol. Symmetric algorithm, it can be known as a secret key algorithm. It transforms data to make it extremely difficult to view without possessing a secret key. The key is considered symmetric because it is used for both encrypting and decrypting. Asymmetric algorithm, it also referred to as a public key algorithms. It is used pair keys, a public and a private key in performing their function. Cryptographic protocols, they are small programs designed to secure communication through security assurance by using cryptographic mechanism. This is the summary of cryptology. Application of cryptology in real life. First, encryption in application of WhatsApp. End-to-end encryption makes sure that a message that is sent to receive only by the intended recipient and none other. It also means that outsider or third-party individuals cannot snoop on conversation between intended recipient as well. Second, digital signature or authentication. A digital signature is a mathematical technique used to validate the authenticity and integrity of a message, software, or digital document. For example, the fingerprints and SIM card authentication. Third, securing email communication. File encryption method to secure email communication where sensitive data is being sent. Fourth, securing network communication, providing data security layer between TCP or IP, the foundation of internet-based communication and application protocols such as HTTP. Fifth, security of electronic money. Encryption is used in electronic money scheme to protect the conventional transaction data like account numbers and transaction amounts. For example, e-wallet.
Terms in cryptology. For plain text, a message that is to be altered into a secret form. Ciphertext, a message that has been transformed into a secret form. Encryption, a procedure method for altering a plain text message into ciphertext by changing the letters of the plain text using a transformation. Decryption, the reverse process of changing the ciphertext back to the plain text by the intended receiver. The scissor cipher and its example. In cryptography, scissor cipher is one of the simplest and most widely known encryption-decryption algorithm. Scissor cipher is a type of substitution cipher. In this kind of cipher, each letter in the plain text is replaced by a letter some fixed number of positions down the alphabet. The scissor cipher named after Julius Caesar, who used it in his private correspondence. Caesar is considered to be one of the first persons to have ever employed encryption for the sake of securing message. Caesar decided that shifting each letter 3 places down the alphabet in the message would be his standard algorithm, and so he informed all of his generals of his decision and was then able to send them secure message. Based on the picture above, with a left shift of 3, each occurrence of A in the plaintext becomes D in the ciphertext, as well as B would become E and C would be replaced by F. Further enhancement to original 3 places shifting of character in Caesar cipher uses modulo 26 arithmetic. According to the sim, A equal to 0, B equal to 1 until Z equal to 25, encryption of a letter X by shift n can be described mathematically as En X equal to X plus n mod 26, while decryption is performed by reversing encryption process with simple shift of alphabet ordering Dn X equal to X minus n mod 26. Example 1. Encrypt. Amir's elder sister asked him to create a strong password by changing the old password to the new password using Caesar cipher by adding the key from each character of plain text to obtain ciphertext. Amir going to encrypt his password MO Amir 684 and decide to use shift cipher with shift 6. So for the solution, we use En X equal to X plus n mod 26. Then we substitute the alphabet, we get Em equal to 12 plus 6 mod 26, congruent to 18 mod 26. And we get S, same goes to other alphabet. Then for the ciphertext, we get SUG SOX.
Example 2. Decrypt. After doing the research about cryptography, Amir gains knowledge on how to decrypt a ciphertext if he gets secret message from anyone by subtracting the key from each character of the ciphertext to obtain the original message. Amir wants to decrypt the message WYVVIRHIV using key shift of 4. Let's look at the solution. By using Dn X equals to X minus n mod 26, we just substitute X with alphabet and n with key shift. First character is W. If we look at the table before, we know W is 22. So, dnW equals to 22 minus 4 mod 26 congruent to 18 mod 26, which is represent S. Second character is Y, which is represent 24 in the table. dny equals to 24 minus 4 mod 26 congruent to 20 mod 26, and we obtain U. Same goes to the next character. We just substitute in the formula by referring to the table and we will get the original character. After finish all the characters in the ciphertext, we can obtain the plain text, which is surrender. Affine cipher and its example. Affine cipher is a type of substitution cipher where letters are replaced by other letters. Affine cipher is an extension of Caesar cipher. It is a cryptographic technique that exchanges monoalphabetic characters. Each letter in the plain text is converted to its numeric equivalent and converted back to the letter based on the formula used. The cipher uses keys in the form of prime numbers in the encryption and decryption process. Encryption function y equals to ex equals to ax plus b mod n. Decryption function x equals to dy equals to a to the power of negative 1 y minus b mod n. Key of an affine cipher k equals to a b, where gcd of a n equals to 1, where n is plain text size, a is multiplier value where a greater and equal to 1, smaller and equal to n minus 1. B is shift key where b is greater and equal to 0, smaller and equal to n minus 1.
Example 1 for encrypt that related to affine cipher. During elementary number theory class, Dr. Iman told Zana to encipher number by using affine transformation with K15 and 20. Zana's answer as follows. Plain text is number N-U-M-B-E-R. The multiplier A is equal to 15. The shift key B is equal to 20. n equal to 26 since the size for alphabet is equal to 26. Based on the requirement, 15 and 26 are relatively prime. From the information given, we can get that the equation for encryption EX equal to 15 times numerical equivalent for alphabet X plus 20 mod 26. So, for the first alphabet N, the numerical equivalent for N is equal to 13. So, EN is congruent to 7 mod 26. For 7 mod 26, the equivalent letter for 7 is H. Same goes to other alphabet. So, from the plain text NUMBER, we can get the ciphertext HISJCP. Example 2 for decrypt that related to a fine cipher. After Zana solved the questions, Dr. Iman gives her another task, which is to decrypt the secret word GEXDKJ by using 11 as the multiplier and 5 as the shift. Then, Zana's answer as follows. The ciphertext is GEXDKJ. The multiplier is equal to 11. The shift B is equal to 5. N is equal to 26. The GCD for 11 and 26 is equal to 1. So, 11 and 26 is relatively prime. The inverse for the multiplier 11 is equal to 19, since 11 times 19 is congruent to 1 mod 26. From the information given, we can get the equation for decryption dy equal to 19 times y minus 5 mod 26. So for the first alphabet G, the numerical equivalent for G is equal to 6. So DG is congruent to 19 mod 26. The equivalent letter for 19 mod 26 is T. Same goes to other alphabet. So from the ciphertext GEXDKE, we can get the plain text THEORY, which is theory. That's all for the example 2 decrypt.